Okay, good evening, everyone.
Good
Uh,
evening, ma'am.
yeah, so today we have V Gates all with us to do a few problems today from V Gate. So here is the first question. The question says, suppose you have a five class classification problem where class label Y belongs to 0 to 4 and each training example Xi has binary features F1, F2, F3 belonging to 0, comma 1. So we need to find out the number of parameters that you need to classify an example using nine-based classifier. So basically, number of parameters that you will have to uh, use here. So you have five labels, okay? So 0, 1, 2, 3, 4, and each example xi has binary features. So if my xi is like f1, f2, f3, each of these will belong to 0, comma 1. Okay, so this is my f1, f2, f3. The y, the label belong to 0, 1, 2, 3, 4. So how many parameters do we need here? If you have to use, if you have to use this using naive-Bayes classifier to classify certain samples. I'll wait for a minute if you need some time. Any answers?
Ma'am, 19.
Okay, okay. Yes, Agra is saying 4. Okay. Anyone else? Four plus 15 is equal to 19. Okay.
19, ma'am.
Yeah. Yeah. So many of you got the answer to be 19, and yes, that's correct. Um, so as the question here says that you have five labels, right? So if you have five labels, you need to know at least four of these parameters. This may be for 0, for 1, for 2, for 3. At least any four you need to know. If you know any four, you can get the fifth one. So for these, we need four parameters. And then for each of these labels, I have three features here, right? So 1, 2, 3, 1, 2, 3. And for each, I need one parameter. So from there, I have 5, 3 times 5, which is 15. So 15 plus 4, total of 19 features we need to, total of 19 parameters we need to know if we have to use naive-Bayes classifier to classify examples. Any example?
Ma'am,
Is it
could you
clear to
repeat
everyone?
once?
Huh. Which part did you not understand?
Ma'am, the 3 cross 5.
Okay. See, this is okay. Four you will need from here. Now, for each of these, so uh, if I look at for the class 0, again I have for every class you have three features, right? So every training example has binary features F1, F2, F3. So this is my F1, this is my F2, this is my F3, F1, F2, F3, F1, F2, F3, right? So for all of this, I need to have one uh, parameters that I have to estimate. And what are those? So let's say for this one, it will be P1 not of hat, right? This will be P not 2 of hat. This will be P3 not of hat, right? So for every label, you will have three of these parameters that you will have to estimate. So you will have 3 times 5 from here, which is 15. Um, Placement. Is it clear?
Yes, ma'am, please proceed.
Okay. So this was simple. Next we have so
Yeah, ma'am. So
hmm,
from where four get four?
uh-huh. Tell me.
Yeah, from where you got four?
Oh, from where did I get four? Um, See, here you have uh, class label. You have 0, 1, 2, 3, 4, right? So if
Yes.
you know any four of these, the fifth one you can estimate because it is just going to be like sum of probabilities has to be one, right? So if you know any four, you can easily find the fifth one, right? Like for example, when you had only two labels, let's say y is equal to 0, y is equal to 1, right? So in this case, I only need one parameter p hat, right? Because if I know p hat, which is probability of y is equal, the estimate of probability y is equal to 1, then I can find out the parameter estimate for y is equal to 0, which is just going to be 1 minus p hat. Now you have multi-class, which is 0, 1, 2, 3, 4. So all these probabilities should add up to 1, right? So if I know any four of it, any four, I should be able to like that is sufficient. Okay.
Yeah. Okay, ma'am. Understood, ma'am.
Um, all right. So here is the next question. Uh, it says a Gaussian Naive-Bayes model is trained on a given data set. For an unseen data point x, the following two values are calculated. So probability x given y is equal to 0 is calculated as zero point 0.4, and given y is equal to 1, probability of x is calculated as zero point 0.6. So you have to find out what is going to be the predicted label for x. I'll wait for 2 minutes. Okay. Now, so Joydev has answered option C. Okay. Okay. So, all right. So most of you have gotten option C here. So yes, that's correct. So what the only information that is given is like if you have this data point, unseen data point X, only two things are given to us here. One is probability X given Y is equal to 0 is zero point 0.4 and probability X given Y is equal to 1 is zero point 0.6. So actually, so you have to find the predicted what is going to be the label for predicted label for X is what you have to find. And for this, how will you calculate this? So this is going to be so to figure out this, you need to find what is the probability that given X, what is the probability that Y is equal to 1, and given X, what is the probability that Y is equal to 0, right? So you need to find out these two probabilities, and only then, depending on like which probabilities are coming out to be bigger, that is the label that you're going to predict. But let's say we are calculating this, the first one, which is probability Y is equal to 1 given X, right? So this is going to be what? This is going to be the probability of X given Y is equal to 1 times probability Y is equal to 1 divided by probability of X, right? This is how you will find it. But we don't know what is probability Y is equal to 1. That information is not given to us. So we cannot just given this information, it is not possible to predict the label for X. So you shouldn't see this one like probability X given Y is equal to 0 is zero point 0.4 and probability X given Y is equal to 0.6. I mean, this is not giving you the like predicted label for X. This is not giving you that, right? This is giving you like given Y is equal to X, what is the probability of X? Given Y is equal to 1, what is the probability of X? But the question asks the other way. So what is the probability that given X, what is the probability of 1? Given X, what is the probability of 0? Okay. So the answer would be C here. Is it clear to everyone? Okay. Let's move to the
Yes,
next
ma'am.
question.
Yes, ma'am.
Okay. So here, the third question says a binary classification dataset contains n examples belonging to 0, 1 to the power 3, such that the first feature values for all n examples are 0. You have to assume that no Laplacian smoothing is done. So given this information, you have to find out the value of P1, not hat. And what is this P1 not hat? This P1 not hat is probability that given the label is 0, what is the probability that F1 is equal to 1? You need to find this. Okay. Uh, yeah, so this is correct. So the answer is 0 here, right? Why is it 0? Because see, the question here says that you have two labels here, y is equal to 0 and 1. So you have y is equal to 0 and y is equal to 1. And you have three features, right? And each of them are binary. Uh, so what uh, what additional information that is given to us here is that um, the first feature value for all the n examples are 0. So if I'm given some n examples to if I'm given some n examples, and in this case, what we are saying is the first feature value for all the n examples are 0. So this is all 0. Okay. So if this is all 0 and we are assuming no Laplacian smoothing is done, then what is the value of P1 not hat, right? So if in the first entry, in the first feature, if it is not even taking the value 1, then this is going to be predicted as 0, right? It is this value, the estimate for P1 hat, P1 not hat is going to be 0. Is it clear to everyone? So I saw many people
Yes,
have
ma'am.
given the correct answer. Okay.
Ma'am, could you please explain again?
Hmm. Yeah. So what part is not clear, Disha?
Ma'am, the last part that you told.
Okay. So see, you have n examples, okay? And the first feature value for all the n examples are 0. This is all 0 given to you. All right. So what is P1? Okay. So what is P1 not hat? So P1 not hat is basically, so P1 not hat is the estimate for probability that given y is equal to 0, my f1 is equal to 1, right? This is the estimate. Now, if you look at all these examples, all these f1 values are 0, right? So how do you find this? So out of all the examples which are labeled as 0, you need to see has how many examples are taking the feature f1 as equal to 1, right? That is how you define this,
Yes, ma'am.
right? So out of all the, so let's say all of these were just The extreme case, like all of these, if it was zero, then I mean, there is no example that where you will find f1 to be 1, right? Because it's all zero. So this term you are going to get is zero.
Okay, ma'am.
Yeah.
Yes, ma'am.
Okay. Yeah. Moving to question number four. So here you have a data matrix X of shape D cross N. So here number of features is three, and you have four training example. Now the label is also given to you. P hat and P hat J of Yi, they are as it was given in the lecture. So P hat is the estimate for probability Y is equal to 1, and Pj Yi hat is the estimate for probability that Y is equal to Yi, probability that Fj is equal to 1 given Y is equal to Yi. So you have three features with you, F1, F2, and F3, right? So this is my F1, this is my F2, and this is my F3. Now, these parameters, that is P hat and P hat J of Y, these two, all the parameters that we will find, we have estimated using MLE. And we have seen in the lecture, like, what are their estimate, right? We have seen what is P hat of ML. We have seen what is P hat YI J of ML, right? We have seen this. We have seen what these values are. Now, there are two questions that are asked here. One is, what is the value of P naught, P3 not hat? Again, you assume that no Laplacian smoothing is done. And the second question asks you, like, if you have a point 100, then what is going to be the predictive label for this point?
Ma'am, there are three features but four levels. How does that work?
There are four examples, no? There are four data point here, right?
Yeah. Acha, acha, acha.
Yeah.
Okay, okay. My bad, my bad.
Okay. Okay, someone has, okay, you have given the answer for second part. Okay. Okay, so many of you have answered in the chat. So option question two, one, and question one, half. Yes, that's correct. So here we have to find what is the value of P naught, P3 naught of hat, right? The example that is given to us, so you have F1, F2, F3, and you have these labels. So you have 1, 0, 0, 0, 1, 1, 0, 0, 1, and 0, 0, 0. The labels that are given to us is 1, 0, 1, 0. Right? So P naught, P naught 3 of hat. So this is what? This is the estimate for probability that given y is equal to 0, my F3 is equal to 1, right? So how do we find this? So what is this, like, given any label y, how do we, like, what is the estimate? We know that this estimate is given by summation I varying from 1 to 1, indicator of fj I is equal to 1, comma yi is equal to y, divided by summation indicator of yi is equal to y. Right? So this basically says is out of all those examples for which the label is y, right? So in this case, out of all the examples for which the label is 0, so these two examples, how many has the how many has a feature f3 is equal to 1, right? So this is just going to be in the denominator. We have two such examples. So in the denominator, we have two. And out of that, I can see F3 is taking 1 for out of these two. So 1 by 2. So the answer is going to be 0.5. Okay. Then for the next part, this is for the first part. For the next part, you have to do what is the predicted label for the point 100. So if you have to find, so for the second part, so what is my X test? My X test is 100. My X test is 100. Okay. So you have to
Ma'am,
find out. Yes.
ma'am, for previous question, my answer is 1 by 2.
See, because in the denominator, what it is how many examples has the label yi to be y. So in our case, y is equal to 0, right?
0. Yes, ma'am.
So of all the examples, so you have four examples given to you. Out of these, how many has yi to be equal to 0? So how many are there? Two. Out of four, we have two. So denominator is 2.
Okay, ma'am.
Okay. So if the denominator is 2, and now you have to look at numerator. So here it says of all the examples where your yi takes the value y, so for yi takes the value 0 in our case, along with that, your feature, so feature should be equal to 1, right? So in this case, we are interested in f3. Probability of f3 is equal to 1 given y is equal to 0. So my f out of these two examples, only for one example, I am getting the feature to be equal to 1, f3 to be equal to 1. So that's why 1 there. And the
Okay,
answer
ma'am.
is 1 by 2, which is 0.5. Okay. Now, for the second part, we have to find probability of we have to find probability of y is equal to 1 given x test, which is 100 by transpose, and we need to find probability y is equal to 0 given x test is equal to 100. Okay, so let's look at the first part. So what does it like? How will you find this? So this is going to be probability that my x test is equal to 100 transpose given y is equal to 1 times the probability that y is equal to 1 divided by probability that probability of this x test, right? Now we know if we use a class conditional independence, they all are it is just going to be probability that my f1 is equal to 1 given y is equal to 1 times probability f2 is equal to 0 given y is equal to 1 times probability that f3 is equal to 0 given y is equal to 1 times probability y is equal to 1. So what is this estimate going to be? From the example, I can see that it is just 1 by 2 because out of the 4, there are 2 for which y is equal to 1. For 2 examples, I'm getting y to be equal to 1. So p hat is 0.5, right? So here it is just 0.5, I can write it, divided by probability of x test. We can leave it there. I mean, it's not needed to solve for probability of x test. So what is this probability f1 is equal to 1 given y is equal to 1? So given y is equal to 1, what is this estimate going to be? F1 is equal to 1. It is just going to be 1 by 2, right?
Yes, ma'am.
So this is going to be 1 by 2. Then given y is equal to 1, f2 is equal to 0. Given y is equal to 1, f2 is equal to 0. So
3 by 2?
both, no, that is given y is equal to 1, right? So you have to look at this and this, right? These two.
Okay, only these two.
So out of these two, both have the entry as 0, f2 as 0. So this is going to be 1,
2 by
right?
2. 2 by 2.
But which is 1. Now f3 is equal to 0 given y is equal to 1. So again, that is going to be 1 by 2. Right? Again, that is going to be 1 by 2 because
So we have to
only
take the value of y and only you have to take the data points of that only, right?
correct. That is how you find the estimate for,
Mm-hmm.
if you remember, that is
2
how
by
we
2,
find
yeah.
it.
1 by 2, 2 by 2, 1 by 2.
Into 1 by 2, again from 0.5. So we get this to be 1 by 8. This is just the numerator part. Denominator part we can ignore because we need to compare these two, right? So that won't matter for us. So what we got is that probability y is equal to 1 given x test is 1 by 8 divided by probability of x test. So that's okay, we can ignore that. Now, if you
Here
look at,
we want to compare this one. The probability of y is equal to 1 given x test is equal to 100 and probability of y is equal to 0 x. We want to
huh,
compare this. That's why we are calculating, no?
yes,
Yeah.
we want to compare these two, right? So
Yeah.
whichever is bigger, I mean, we'll say that is the prediction. But now, if we have to find for probability y is equal to 0 given x test, then what happens here? In place of y is equal to 1, now you do y is equal to 0. So what it says is probability that f1 is equal to 1 given y is equal to 0 times
Is it
probability f2 is equal to 0 given y is equal to 0 times probability f3 is equal to 0 given y is equal to 0 times probability that y is equal to 0, right? So now if you see this, I mean, now you have to look at for y is equal to 0, right? So for y is equal to 0, if 1 is equal to 1, you don't have it, right? So this is going to be straight 0. So if this is 0, the whole thing basically is 0.
As soon as we get the zero value, then we do not need.
Yeah, we don't need to compute anything, right? Because it's just multiplication, so it will just get cancelled out. So what we got here is that probability of y given, probability of y is equal to 1 given x test is greater than probability y is equal to 0 given x test, right? So we'll predict y to be 1.
1 because probability is high. And
Ah.
what was the question? Just saw the question. Why did we
Yeah.
compared it?
So you have to find what is the predicted label for the point.
Which question? What will be the predicted
This
level
question.
for the point? Okay, okay. We want the level. Okay.
Yeah, we want the label.
Yeah. For the
So you
prediction,
need
we need the probability to be compared,
You
right?
need to compare the probabilities. Yes.
Compare the probability of each level. Suppose
Yeah.
if
So you have to. So
suppose it is
this is
three
the
levels.
X test, right?
If 3 levels
This
are there, then no comparison can be made. No.
it can be made, no? I mean, you'll have to check for all the possibilities.
Okay. Okay. Okay.
So
Yeah.
here my X test is 100. My X test was 100 transpose. We need to find the predicted label for this X test. So we need to find the label, right? Predicted label. So we need to check probability y is equal to 1 given x test and probability y is equal to 0 given x test. So we need to figure out which one is bigger, whichever probabilities are bigger, we are going to predict that as the label for this test data point. Okay, so in this example, we got y to be equal to 1. So for this, the answer is 1. The answer is 1. And for this, the answer is 0.5. All right.
It is already directly present in the testing phase. So we can directly say it's 1. We don't need to calculate, right?
Oh, okay. Yeah, you're right. You're right.
Pardon? What was the confusion?
No. The test data point that is given is actually in the trailing here. Didn't notice that.
Okay, the test itself is given, and the basic.
But the answer may be different.
But
We actually had a similar example last time. We need to do this, otherwise
okay.
your answer might be different. Answer even can come out to be 0 as well. So you cannot leave it like this. But although this
Yeah,
is in the data point, 100 in the data point level as 1, answer may come out to be 0 when you actually work out. So you need to work out. You cannot leave it since it is already in the existing data.
Directly, we cannot say that if it is
Directly you cannot say, because there are examples when it has become opposite.
Hmm.
It can be 0 even.
You have seen this example when?
Yeah. There is some example. I think previous day only we actually worked out, and it came out to be different.
What is the reason? Man, color showed. Actually,
Wait,
ma'am,
wait. Say it again. I can't hear you.
What is the reason behind this for this two different labels for only one data set? Two different labels for the same data set. How is that possible?
Uh, See, this is a training. This is used in the training. Basically, your these things, right? This is a training example that is given to you. But not sure. I mean, the data should have been different, I feel.
Then is that the reason that we have two labels like 0 and 1? So there are different probabilities for the label y equals to 1 and the for y equal to 0. Is that the reason?
What? There are different probabilities for y is equal
Like we
to
have
0.
two, for one data set, we have different probabilities if y equals to 1 or y equal to 0. Both can have different probabilities.
You're saying this that no, what probabilities you're talking about?
Labels. Labels means if y label is y equal to 1, then the probability
Mhm.
will be different. If y equal to 0, then the probability will be different.
Oh no, that you're saying that if xis are same and the labels are different. You're talking about that, right? Um, but here again, that see these can also vary because all these estimates that we find
Like in one of the lectures, sir has explained that if a word comes in our data set, then the probability of coming or getting that word for for label y equal to 1 is different, and for label y equal to 0 will be different. I'm thinking
no,
in that.
that is okay. So you are talking about this thing, right? You're talking about um. So if you have X test to be maybe something you have, and maybe this is DH feature, and probability that Y test is equal to 1 given this X test, and probability that Y test is equal to 0 given this X test.
Yeah,
You're talking about this, right?
yeah, yeah.
They are, I mean, that this is a different thing, no? Because um, it also depends on from which class your data set is, like what is the estimate there?
But here also, ma'am, the class is different, no? If same data set have different classes, that's why we are calculating it again. Means we have only one data set, and for the same data set, we have two labels. Either it can be 0, either it can be 1.
It can be, but okay, not really sure.
The standard. What
That
is
was
the
about,
standard? Standard.
see, I mean, standard is like what we have discussed here.
Algorithmic method.
Yeah, this is how we do it, right? I mean, if you're given any test data point, how will you predict the label? I mean, this is how we calculate it. We have the set of examples given to us.
Yeah.
From there, we find the estimates, and these estimates are basically these, right? P naught, PJY hat. These are the estimates, and P hat. In case you have a binary classification problem, then you have P hat. So you find all these estimates using the examples that are given to you, and based on that, I mean, use all this information to find the predicted label.
Where we are using this one
What
P
what?
P0 P03 and P P Y J. This
P
information
zero
we are not
P0
using here, no, for estimate for
P,
predicting.
P03 was for the first part.
No, in the question note, in the standard for predicting a data point for
We
a
are using, right? How did you find all these things? How did you find these? How did you find this? How did you find this? You use this, right? You use this formula for estimation. I mean, these ML estimates you have used,
correct.
right? So we have used these,
Right, right, yeah.
right? Okay.
What is the solution
Um,
of this?
yeah, so the answer for the first part is 1 by 2, and the
Okay.
answer for the second part is label by.
How did you decide? It's for a label for a class 0,
Uh-huh.
there is no feature available. So,
There is no feature, so that probability goes to 0.
so that becomes 0.
Uh,
So obviously that
so
you will not
straight
be,
away it becomes 0, right?
yeah, it's straight 0 because of that
Mm.
non
Because of
not smoothing.
this thing.
So is it allowed? I mean,
Is it allowed as it?
one feature becomes not available,
Hmm.
then the whole probability likelihood becomes 0. That is why
The
it,
whole, yeah, the likelihood becomes 0. And that's why the Laplacian smoothing comes into picture, where
credibility
we
of
add
the
two
test becomes a
dummy
question, right?
examples.
The
What?
credibility of the test, credibility of the logic or an algorithm becomes a question. That is why we do the smoothing. When
That's why
suppose
we do this smoothing, yeah.
if they specifically said no smoothing, then what kind of answer we are supposed to give?
So if says no smoothing is done, it means whatever we have done right now, that is the answer, right?
We are
Because since no smoothing has been done,
Mhm.
straight away this is going to be 0. If this is straight away going to be 0, then this whole probability that y is
Other one
equal
is
to,
non-zero, then that becomes the point.
then it becomes a point, yeah.
Okay, by default.
Then you need to calculate both and do it.
All right.
Yes.
In smoothing, you
Somebody.
will put some dummy data in smoothing.
For smoothing, you need to put two dummy examples, right?
Two dummy
One is
examples
where all the features take value 1. One is where all the features
with
takes the value
with
0.
features 0.
Uh,
Okay.
Anybody had something? I heard someone saying something. Hmm. Okay, let's move to the next question. So here again, you have uh, a data matrix given to you, which is X, and you have Y, which is 0, 1, 0. That is a label. We know the usual estimates we had done, we had J of Y is given to us. And the question here says, if a test point has label 0, then what is the probability that the point is 0, 0? So here what you have to compute is uh, what is the probability that X test is equal to 0, 0, given that Y test is equal to 0. This, this is what you have to compute. 5. So there are 3 answers in the chat. Okay. All right. So yeah, here again the answer is half. So this is what we have to find here. That is, given y test is 0, what is the probability that x test is equal to 0, 0, right? So how can we find this? So this is just going to be probability that my f1 takes the value 0, given y is equal to 0, times probability that f2 takes the value 0, given y is equal to 0. That's all right. This is what all we have to do here. So now, if you see, given y is equal to 0, f1 to be 0. So that is in both case, here also and here also, right? So this is going to be 1. Now, given y is equal to 0, probability that f2, oh sorry, f1 was 0, right?
It is 1 by 2, no?
F1, yeah, 1 by 2, 1 by 2.
1 by 2, no?
F2 is equal to 0, this is 1.
1.
So this turns out to be 1 by 2. So the answer is 0.5. Right? I hope this was straightforward. I hope this is it clear to everyone? Why is it 0.5?
Yes, ma'am.
Okay. So 0.5 is the answer.
We are using here the class independence formula, no? 0, 0.
Class independence is.
F1, F2 is the class independence.
That's why you're able to write this as
Multiplication, right?
Mm.
And how we decided that this was class independence?
Because we're talking about naive-based classifier, right?
Okay,
And
that's
one assumption is the class conditional independence.
okay. Already naive based mentioned, right?
Mm. All right. So this is another question. So here it's a spam classifier. Basically, you're working on line-based classifier, which will help you determine whether an email is spam or not spam. So it says you have trained your model using a data set of 1,000 emails. out of which 600 of them labeled as spam and 400 of them labeled as not spam. So if you have 1,000 data set, 1,000 emails, I'm saying 600 are spam and 400 not spam. Now you have collected statistics on the occurrence of two words. So we are looking at two words here, just two words. One is one and the other is money. So for the keyword one, the label of the email is spam. So probability of one given the spam is 0.45. Probability of one given not spam is 0.05. Probability of money given spam is 0.3. And probability of money given not spam is 0.42. So these probabilities are given to you, are known to you. Now you receive a new email that contains both the words, which is one and money. Okay, and uh, that email now you want to classify whether it's going to spam or it's going to go to not spam. So use the 9-base formula to calculate the probability. So basically, now you have this email which has both the words. So it has the word one also, and it has the word money also. So if that's the case, what is your algorithm, 9-base classifier, going to predict this email as? So you have to assume that there are only two words, which is one and money. That is, there are only two features that is given to you in the question. So you have to calculate the probability that the new email, I mean, the email that you have there that has both the words one and money. What is the probability of that email being classified as spam? I'll wait for some time. This may take some time to solve. Maybe I'll wait for some time and then I'll proceed with the solution.
Is the answer 0.9977?
Yeah, approx, yes. Others, please try this. Okay. Um, yeah, so 0.995 is the correct answer. Visha, 0.75 is not correct. So let's see. What we have to find here is you have to calculate the probability that the new email is classified as spam. So what is the probability that y is going to be 1? So considering I'm taking spam to be 1 and not spam to be 0. So probability y is equal to 1 given my x test, which is word 1 and money. So I can instead write this as feature 1, feature 2. Okay. So feature 1, feature 2. Transpose. So feature 1 I have taken as 1 and feature 2 I have taken as money. So we have to find this probability. So again, how will you find this probability? This is going to be probability. This is going to be probability that my x test, which is f1, f2 transpose times given y is equal to 1 times y is equal to 1 divided by probability of x test, which is going to be probability that my x test is equal to f1, f2 transpose given y is equal to 1 times probability y is equal to 1 plus this whole thing again, which is probability that x test is equal to f1, f2 transpose given y is equal to 0 times probability y is equal to 0. So that's all we have to solve, right? Here we cannot ignore the denominator because we have to find the exact probability. So I know what is probability of y is equal to 1 and what is probability of y is equal to 0. Because 600 out of 1000, so out of 1000, 600 was spam and 400 was non-spam, not spam. Right. So my p hat is going to be 600 by 1000, which is 0.6. Right? And p hat is basically the estimate for probability y is equal to 1. Now, again, we use the class independence condition now. So what do we get? This in the numerator, which is probability of f1 given y is equal to 1, which is probability of 1 given the spam, it is given to be 0.45, right? So this is 0.45 times probability that. So this is probability of f1 given y is equal to 1, right? So probability of 1 given spam. So probability of 1 given spam is 0.45. This is given to us.
Yeah. One is the f1, right?
Now probability of f2 given y is equal to 1. That is probability of money given spam. So probability of money given spam is 0.3. This is 0.3. This is 0.3. 0.3. And probability y is equal to 1. This estimate is 0.6. Right? And divided by, so you write all this whole thing will come here, plus probability y is equal to 0 is going to be 0.4. So 0.4 times probability of 1 given not spam. Probability of 1 given not spam is 0.05. So this is 0.05 times probability of money given not spam. Probability of money given not spam is 0.02. So 0.02. Right? If you calculate this, you will get 0.995. So this is the probability of this email coming from the spam word, which is 0.995.
So the blank bracket in the blank bracket,
And this, no, I said the blank bracket, you write this whole thing. So 0.45
into
times
0.3,
0.3, 0.6.
so the same thing will come.
Yeah, because it will base rule, right?
Mhm. Okay.
Okay. All right. Let's move to the next question.
You will share this slide, ma'am. We written what we are
Yes. So, this will be shared
today only.
today. Only not possible, but tomorrow it will be shared.
Okay.
Okay. So here you have a data set of 10 objects. The attributes given or the features are the color, type, and origin. And this is my class. This is a class. So basically, this is yes or no. The class is yes, no. And if you see all these features, that is color, type, and origin, they all are binary classes, right? So it's more like the color is either red or yellow. Type is casual
Or formal.
and formal. Origin is, I think it should have been mentioned in the question also, but okay. Domestic and imported. Okay. So each of these features are also kind of binary. So you have color either red or yellow, type either casual or formal, origin either domestic or imported. Now, if you get a new object with the properties that color is red, type is formal, origin is domestic, then what is your naive Bayes classifier going to predict the label for this test instance? So you have to calculate this, whether it will predict yes or whether it will predict no. Maybe you can think of yes as 1 and no as 0. Okay. I'll wait for 2 3 minutes here. Um, Avra here, you don't, I mean, it is not asking the probabilities. It is asking whether it's going to be yes or no. Okay. I see all of you, whoever has answered has gotten answer to be no. So let's see the solution. Okay. So you need to check probability y is equal to 1, which is yes, given that x test is equal to red, formal, and domestic. Okay. So maybe the color I will write it as F1. Type I will write it as F2, and origin I will write it as F3. So probability that you need to find probability y is equal to 1 given x test is equal to F1, F2, F3. So again, since these are all binary, maybe I can code red as 1, yellow as 0, casual as 1, formal as 0, domestic as 1, and imported as 0, right? So this is going to be probability y is equal to 1 given x is equal to, so I'm saying F1 is for color. So color we have to see as red, and red I have coded it as 1. So F1 to be 1. F2 I have coded it as for type. So F2 is for type, and type should be formal, and formal is coded as 0. So F2 is 0, and F3, which is origin, and origin domestic we have to see, and domestic is coded as 1. So this is what you have to find out, right? So you need to check what is the relationship between probability y is equal to 1 given x, which is 1, 0, 1, and probability y is equal to 0 given x is equal to 1, 0, 1. Whether it is greater than, whether it is less than, whether it is equal to, you need to figure out.
How
So,
designate the 101 once again?
so no, what I have done is, since all these features, which is color, type, and origin,
Yeah.
they all are also binary, right? I mean, they're taking in a way it's 1, 0, right? I can
Yeah.
code it as 1, 0
Yeah.
because if I look at color, it is either red or yellow.
Color
Type
is
is
F1. Color
casual
is
or formal.
okay.
Origin is domestic or imported, right? So I have coded it like
Okay.
this.
Okay.
So red I have coded as 1, casual I've coded it as 0, and domestic I've coded it as 1. So that's why I mean we had to find for this, which is X test is red, formal, and domestic. So red is 1, so I have written 1. Formal is 0, so I've written 0, and domestic is 1, so I've written 0. So what is the probability that y is equal to 1 given x is equal to 1, 0, 1? Okay. So again, this is more like comparison, and uh, like we have solved questions like this, but here it is given in a different way. If you can write it in terms of like numbers, it becomes a little easier. So now it again, it's like the same kind of question. It turned out to be the same thing. Now you need to find out these two things, right? So again, this is comparison, so denominator won't be needed because in both the cases, denominator is going to be same. So what I need to check is what is the probability that X is equal to 101 transpose, given that Y is equal to 1 times probability of Y is equal to 1. And what is the probability that X is equal to 101 transpose given Y is equal to 0 uh, times probability of Y is equal to 0. Okay. So from the table, let's first find out what is Y is equal to 1, what is Y is equal to 0 by estimating. So there are 10, oh, numbers are 6, 7, this is 10. This is 10. So there are 10 examples. And out of these 10, I can see 1, 2, 3, 4, 5. 5 taking the label class as yes. So another 5 is no. So P hat, the estimate for probability Y is equal to 1 is 0.5. So this is also going to be 0.5. Okay. So again, this also both sides equal. So doesn't matter. I mean, we can ignore this again. Now, what is this going to be? So this is going to be probability that F1 is equal to 1 given Y is equal to 1 times probability that F2 is equal to 0 given Y is equal to 1 times probability that F3 is equal to 1 given Y is equal to 1. Okay. So if we can find this, so given Y is equal to 1, what is the probability of F1 to be 1? So F1 to be 1 is what you have to look for. So 1 means red. Okay. So look for all the yes columns or yes rows and see how many has the color to be red. So we can see here there is 1 red, 2 red, this is yellow, this is again yellow, and this is red. So 3 out of 5 is red. So this estimate, this probability estimate is going to be 3 by 5. Okay.
Pardon,
next is
one second, ma'am. F1 is equal to
so
1.
F1 is 1 given Y is equal to 1, right?
Okay.
So Y is
F1
equal to 1 is for satisfied is equal to yes, right? And F1 is for color, and F1 is equal to 1 means color is equal to red, right? So I will look at all the rows for which satisfied is yes. So these are the rows I can see satisfied is yes. Now look at this F1. So look at this F1. So out of all the rows in which we had yes, satisfied as yes, how many are red? So 1, 2. So in this, when I see that this is yes, but color is yellow, so this will not be counted.
Okay.
Again here, yes, it is yellow, so it won't be counted. And at the end, yes, it is red. So there are 3 out of 5. So the estimate here is 3 by 5. So 3 by 5 I have written. Now, what F2 is equal to 0 means given satisfied is equal to yes, what is the probability of F2 to be 0? That is type is equal to type is equal to formal.
0 is 0 is
0
for
is for formal.
uh,
0 is for formal, right?
type is
So, now look for formal in F2. So this is yes, but it's casual. This is yes, this is formal. So you have 1. This is again casual, so won't be counted. This is yes, this is formal, so 2. And
2.
this is again casual, so 2 by 5.
2 by 5.
Right? So 2 by 5. Now probability F3 is equal to 1 given 1. So given satisfied is yes, probability that origin is domestic, right? So now you'll have to look for domestic. So you have 1, you have 2,
2.
then here it is imported, here it is imported, it is imported. So 2 by 5. So this is how much? This is uh, 6, 12 by 125, right? Yeah.
12 by 125.
Right. Now look at the other side. If I look for Y is equal to 0, this is going to be what? This is probability F1 is equal to 1 given Y is equal to 1 times probability that F2 is equal to
Y is equal to 0, no,
sorry,
ma'am?
0. Y is equal to 0 times probability that F3 is equal to 1 given Y is equal to 0. Right? So now you have to look for no case.
Red and
I
no.
mean,
Red and no.
satisfied is equal to no. So given satisfied is equal to no, what is the probability that color is equal to red?
Red
Right?
and no.
So you have to, this is 1.
1.
This is yellow, so won't be counted. This is
2 by 5.
this is 2. 2 by 5. So we got this to be 2 by 5 times. Now F2 is equal to 0. It means you have to look for formals.
Formal and no.
Formal is formal and no, right? So no formal. So this is 1.
2.
This is
3 by
2.
5.
This is 3. So 3 by 5. This is 3 by 5. And what is F3 is equal to 1? That is domestic, you have to see. So in no, you have to look for domestic. So 1, 2,
3.
3.
3 by
So
5.
3 by 5. Right? This is 9 to 18 by 125. Right? So we can easily see that this probability is bigger, right? I mean, this part is bigger for us. It's not the exact probability, but since we just start to compare the like the label, so doing this much is sufficient for us. So we can see the no side you have a higher number. So your
Ma'am, we also need to
algorithm.
multiply. Sorry to interrupt, but
No,
we also need to
I have
multiply
I
that.
have ignored it. Yeah, I've ignored it because it's
Yeah,
just going to be
because it's yeah. Otherwise, we
point
need
5,
to
right?
multiply it. Yeah.
We need to multiply. Yeah, I have ignored it. I had mentioned it before this. Yeah? So,
Just comparison is required.
no. I mean, in case this was not point 0.5, then you multiply and see. Okay.
Yes,
But
yes,
here it was same, so I ignored it.
yes.
Okay. So we can see that it is going to predict the label for this red of red, formal, and domestic. So for this test data point, it is going to predict y to be
0.
0. That is
Y
no,
is 0
right?
is no.
Satisfied no. So
What,
this is the answer.
what is the answer? Use naive to predict the level for
This is
the
going to predict no.
test instance. No, satisfied.
No, yeah, satisfied is a class, right? So it is going to predict no because no we have taken coded it as 0 and we got this probability is higher. So it is going to predict
Satisfied is
no.
the level, right?
Satisfied is the class, yeah.
Okay, got it, class.
Yeah.
Different question here. Any more questions are there?
No, this was the last question. This was the last question.
Mhm.
Um, any doubt here?
Are you going to anything
Okay.
more, ma'am?
No, this was the last question.
Okay. Should I leave?
Yeah, you can leave. Yeah,
Thank you.
I will get this uploaded. Yeah. All right. Yeah. Yeah. Thank you, everyone.
Thank you. Thank
So
you.
this. Yeah. Thank you.
Thank you, ma'am.
Yeah.